today's class of our solar system and the Earth. Let us do a small recap. We have understood the Goldilocks conditions for the formation of the solar system and the planets, and we have understood what is accretion, how the leftover particles of the nebulae, which is the chemically rich matter, gravity, and the supernovae, resulted in the formation of the accretion disk, and further, the accretion disk resulted in the formation of the planets. So, in our today's class, we will be understanding how young Earth was and what is the structure of young Earth, what are the different layers of Earth, and whether life could exist on young Earth. If you see today's atmosphere, it is so cold and there is a slight wind. Did young Earth have all these? And you can see life everywhere with greenery too. Did young Earth have life on it? Could life exist? All these we will be inquiring in our today's class. Let's go for the session. Well, after observing the nature and how life is on Earth today, let's go further and deep dig into young Earth, how it looked like, and what were its features. Here is a task for you. Read the instructions, see the picture on your screen. Next, pause the video and with the picture, write in 60 seconds what you want to write about the picture. It can be describing it, or narrating an incident, or cooking up something from the cosmos. However, stick to the big history project norms. During the star formation, there was abundant hydrogen which was fusing and becoming helium and other elements. But by now, there are many elements in the universe which were forming from the dying stars. The stars' formation and supernovae became a regular cycle. This picture shows how dust particles, gas, and chemically rich matter has formed a flat disk and is swirling. Do you remember your yesterday's activity in which you drew the spiral concentric circles the same way and matter was getting closer and closer because of gravity? Now we have oxygen, carbon, silicon, iron, sodium, magnesium, copper, and many more other elements in the universe. During the star formation, we saw that there was 98% hydrogen and helium and 2% other elements. But now we look at the earth, we see that 10% is hydrogen and helium and 90% is the other elements. So that's what is the main difference in the star formation and planet formation. What was young Earth like? Do you all like to attend a volcano party? Didn't get me right? Well, a volcano party is just like walking across the lane during Deepavali, where there are crackers bursting under your feet with smoke everywhere, falling short for breath. Do you like it? No, right? That's how the young earth was, burning, blasting off the material. A picture like this on your screen will definitely help you understand. Now, what happened? The earth was cooling slowly and the crust was forming. Though the earth was hot and molten from inside, a small observation. What happens when you leave your hot glass of milk on table for some time? You see a layer of cream on top, right? However, at the bottom, your milk is still liquid and also hot. The same way, the earth was cooling and getting hard on the surface. However, the molten lava was still in liquid or semi solid state. How did our moon form and how do we know? The moon was wandering body like an asteroid. that formed elsewhere in the solar system and was captured by Earth's gravity as it passed nearby. In contrast, accretion theory suggested that the moon was created along with Earth at its formation. There are, however, many theories, and let's look into this theory that the Earth or the moon and the Earth formed together and they were separated because of their mass. Finally, according to the fission scenario, Earth had been spinning so fast that some material broke away and began to orbit the planet. When the Apollo mission brought rocks, they showed that the Earth and the Moon have some remarkable chemical and isotopic similarities, suggesting that they have a linked history. So, the soil and the minerals which the Moon and the Earth had looked similar. But however, there was a lot of difference in the humidity and the water content of the minerals which were there on the moon from that of the earth. So there is a lot of ambiguity in this theory too. Having a moon as large as our moon having a moon as large as ours is something that's unique in our solar system. While other planets have tiny moons, the Earth's moon is almost the size of Mars. If you look at other similar planets to ours, they wobble quite a lot in their orbit. They spin in an imbalanced way, and as a result, the climate is much more unpredictable on the other planets. How did the atmosphere around the Earth form? As Earth cooled, an atmosphere formed mainly from gases spewed from the volcanoes. That means the gases which were let out from the volcanoes that were still bursting on the young Earth. It included hydrogen sulfide, methane, and 10 to 200 times as much carbon dioxide as today's atmosphere. Such poisonous gases. Will life exist? No, right? After about half a billion years, Earth's surface cooled and solidified, enough for water to collect on it. The high temperatures of the early Earth caused water vapor and other gases to be released from the Earth's surface, forming a blanket of steam around the Earth. This steam, supplemented by other gases, thickened over time and became the first atmosphere. The buildup of denser gases in the young atmosphere kept some gases from escaping into space, which further thickened the atmosphere. This buildup allowed for the further insulating, heating, and melting of the surface of the earth. In our today's class, you will be reading the articles on the similar fashion from lesson 4.1 and watch videos and answer the key questions. Get ready for the Google Meet with your doubts and discussions. Let's meet in the Google Meet. How did the